Related rates question, we have a sliding ladder. A 20-foot ladder leans against the side of a building. If the top of the ladder begins to slide down at a rate of 3 feet per second, how fast is the bottom of the ladder sliding away from the wall when the top of the ladder is 12 foot off the ground? So, we need to draw a diagram. So here is our building. Here is our ladder. So call the ladder L, and this is 20 feet. So we have our ground. So Y, and we have X. So what are we told in the question? So we have our 20-foot ladder. So a ladder leads along against the side of a building. It says it begins to slide down at a rate of 3 feet per second. So it is sliding down at minus 3 feet per second. So this is going to be dy dt. So this is the rate of change of y. And then we also know that the ladder is 20 feet. X, we need to find X and Y. So let's have a look at the question. So it says, how fast is the ladder sliding away from the wall? So the ladder is going to slide this way. So we need to find dx dt, which is the rate of change of X in relation to time. And it says when the top of the ladder is 12 feet off the ground. So we're looking when Y is going to be 12 feet. So we don't know X. So we need to find X. So we can do this. We'll notice this is a right angle triangle and we can use Pythagoras. So first thing we'll do is use Pythagoras. And Pythag tells us that the longest side, which is L squared, is equal to X squared plus Y squared. So if we take the root, so we have, well actually let's rearrange first. So I want to find X squared. So X squared is going to be L squared minus Y squared. So X is going to be the root of 20 squared minus 12 squared. So 400 minus 144 is 16. So we know that X is 16. So this is feet. So we're looking at the rate of change of our dx dt. Okay, so let's differentiate. So we need the equation. So I'm going to use the equation that we have here. So we have 2L, and because we're going to do this with implicit differentiation, we're going to have in respect, so dl of dt. Now the rate of change of the ladder doesn't change, so this is just 0. And this is equal to x squared, so we're going to have 2x multiplied by dx dt plus y squared. So this is going to be 2y multiplied by dy dt. So we said that this is going to be 0 on this side. So 2x, so we got 2 multiplied, well actually I'm going to divide everything by 2 first. So let's divide all of our equation by 2. So this will simplify. And then we have 0, because if we differentiate the length of the ladder, that's just 0. And then we have, so dx dt, we got x is 16. Dx dt, we don't know. Y, we said is 12. And the rate of change is negative 3 feet. So let's rearrange. So we got dx dt. So this is equal to negative 36. If we take that, add it to both sides, we'll have 36 feet divided by 16. So let me just do that again because you may not know what I've just done. So dx dt. So this now is negative 36. So I'm going to take it the other side, so it'll be 36. This here, if I divide both sides by 16, so we'll be dividing by 16. And dx by dt, or the rate of change of the ladder. So that is, the ladder is slipping away. It's moving at a rate. So it's increasing at a rate of 2.25 feet per second. We're working in seconds.